In this video, we're going to be talking about topic 6.1 and 6.2 and asking the question, how do you approximate the area under the curve with Riemann and trapezoidal sums? So we have four I can statements that we're going to be looking at. So I can explain the meaning of the area of a graph of a rate of change in context. I can find the area under the curve using left or right rectangular approximation. I can find the area under the curve using a midpoint approximation, and I can find the area under the curve using a trapezoidal approximation. So before we get into these notes, I wanted to kind of thinking about, have you think about this. So the first thing is do we know how to find the area of that object there? I think we would all know that that's either base times height or length times width because it's a rectangle. And then my question is, do we know how to find the area of that object? That's a triangle, so we would know it's 1/2 base times height. But could we find the area of this object? Or that one? Or that one? Or that one? We know they're all regular polygons, and somewhere back in geometry, we know we saw area formulas for those, but I do not remember them. I haven't taught geometry in a really long time. So what if we divided it up into objects we do know how to find the area of? So what if we did this to it? Now could we find the area, right? Because if we split them into triangles, all I have to do is find the area of the triangle, then multiply that area times 5 or 6 or 8, okay? So the question is, so we know that we can take an object and we break it up into stuff, we can find the area of it. So now my question is, we find the area of that object. So let's think about it this way then. What if I put that on an XY axis? So now we can see that it's a curve that's on the XY axis. And what if I broke it into maybe some rectangles? I could estimate the area because I know the area of a rectangle. I could break it into rectangles a little differently. That would give me another estimate of the area. To make it better, what would make it better? What would make my estimate more accurate? Maybe if I added more rectangles. Do you see how the gaps underneath the curve and above the curve are becoming smaller and smaller? So the more rectangles I put in there, the better my area is. So that's what we're going to do in this section is we're going to estimate areas under the curve, which is eventually what we're going to get into seeing the calculus of. But we're going to you have to be able to do this by the estimates. So the first thing we're going to do is we're going to draw some pictures here. So we're going to start with the left. So we're going to draw rectangles from the left, and it's important to understand how to draw these because it helps us answer questions later on. So I'm just going to break these up into rectangles that are width 1, and I'm going to go 1. I'm going to start at the curve. I'm starting from the left height. So I'm going to go, and then I touch that height, and then I just trace the box. Then I'm going to touch the next height, and I'm just going to trace or draw over to the next line. Then I'm going to get my next height and draw over. And then my next height and draw over. We'll do one more height and draw over. That's good to just practice. So that's when I have an increasing function. That's what a left rectangular approximation does. Let's try this from the right side now. So this time instead of starting from the heights from the left side, I'm going to start from the right side. So kind of missing part of my curve here if I'm going to do this for 5. So if I start from 5, I'm going to trace all the way up until I hit the curve. Then I'm going to go one segment over. And then I'm going to go on my 4 all the way until I hit the curve and draw it over. And I want to practice these because it's important that we understand how to draw these. I'm going to go all the way till I hit the curve and bring it over. And then let's see, all the way until I hit the curve, bring it over. And finally, all the way until I hit the curve and bring it over. And this is what we would consider coming from the right.